All right, so as you're copying this example is solving an equation that includes factorial notation. And so we really, when we're asked to solve, we are asked to find out what n could be. Now, it could be one or more than one different options, really, which we'll see in some further examples. But this example, we're going to take everything that we've learned in examples. Well, I guess I don't have the solutions for these here, but in examples like these where we expand or we sort of rewrite the factorial, divide out common factors, we're going to have to use that sort of stuff as we solve this problem. So back here, okay. So what you want to do is you want to figure out what this left side, what this actually kind of simplifies down to. So n plus 2 factorial is n plus 2 times n, we take away 1 from 2, that's n plus 1, and that's factorial. And underneath here, in the denominator, we have n plus 1 factorial equals 14. Okay? And just like we've done before, we can simplify the left side, so we have n plus 1 factorial. That is n plus 1 times n minus 1 times n minus 2 times n minus 3, all the way down till we get to 1. And that's the same on the top and the bottom there. So now what we've done is we've simplified the left side to n plus 2 equals 14. And so this becomes really easy, just a simple algebraic solution. Okay? We're good? The next level, the next type of question would involve the same sort of thing, except now we have, well, I'll show you what this is going to look like. Same type of question. Let's see what we have here. And I've got some stuff I didn't erase here yet. Hang on. Okay. So let's do the same thing. N factorial really is n times n minus 1 times n minus 2. Oh, and I can write just factorial after that, because on the bottom I have n minus 2 factorial equals 90. So simplify as much as you can the factorial side. So this goes with this. Now what I have left over here is I have n times n minus 1 equals 90. Okay, we're getting close. Of course, we want to expand the left side, and what we're going to see is we're going to have n squared minus n equals 90. And in this example, we can't solve for n, right? Instead, what we have to do is we have to figure out another way to solve this, because we have two n terms. And you may remember that this is a quadratic. That's a quadratic equation. Do you guys remember learning about quadratic equations in previous math classes? Maybe, maybe not. Some are nodding, some are not. So a quadratic is where we have an n or x, or a squared term anyways, where the variable is squared. And what you can do is there's two different things. You can use the quadratic equation, or the formula, to solve for n. The quadratic formula, you guys remember the quadratic formula? Remember the song? X equals negative b plus or minus root b squared minus 4ac all over 2a. Right. And so a here is 1, b is negative 1, and c is negative 90. So if you put a, b, and c into this and you solve, you're going to get your answers. And there's probably going to be two possible answers that this formula might get you. Another way to do that is not using the formula, but what you can do is factor this quadratic and use the zero product principle. So what I mean by that is this. So factoring this, it can be factored into two binomials. N is going to be the first term in each binomial, because remember, when you expand this out, n times n is going to have to give you this first term. So it's going to be n and n. And then we're looking for numbers that multiply to negative 90 and add to negative 1. So negative 90, what are the factors of negative 90 that have a difference of 1? Well, it's going to be 10 and 9, right? 10 times 9. So how can we, well, negative 10 and positive 9 will multiply to negative 90 and add up to negative 1. And so you have n minus 10 times n plus 9. Does that ring any bells for anybody? Do you remember that from math classes past? Okay. So you're going to have to use one of these two methods to solve for x, or for n in this case. So what does that give us? Well, n here, the zero product principle says what value for n will make this 0? Well, that value is 10. What value for n will make this 0? Because remember, we have to multiply these two to equal 0. So one or both of them have to equal 0. So n plus 9, if that were to equal 0, n would have to be negative 9. Okay? Now, we have two possible answers, but for factorial, this is really important. I haven't mentioned this yet in this lesson, but you only consider positive numbers in these factorial equations or situations. So we can't have a negative value for n factorial. Because remember, the definition of factorial is it starts with a number, and you multiply all of the numbers that are one less than that number until you get to 1. So it doesn't include any negative numbers. So that means we would reject negative 9 as a possible solution. Okay? So it looks like our answer here, n equals 10. And if we state that n equals 10, we're going to want to check. And so just to speed things up a little bit here for this lesson, I will show you this. The check, if you put in 10 factorial, or 10 in for n, you have 10 factorial over 8 factorial. And if you simplify that side just like we did, then we have 10 times 9 equals 90, and that is correct. Okay? Because the 8 factorial will divide out. So it's a good idea to kind of do a quick check. And this is how you would do the quadratic formula. That looks a little complicated, but it's not that bad. You get to the same answers. Okay, so that's how to solve a factorial equation. Anybody have any questions about those examples there? That's the toughest part of this lesson.